Welcome all. I'm Sunil. The topic I've chosen for the thesis is suicidal ideation detection using text graph convolution neural network. Yeah, let's get started. This is the content which I'll be touching upon in my presentation. So I'll jump onto the background part of it. Suicide is the fourth most cause of the death as per WHO recent report. The main causes of suicide, if you see, it is like mainly to deal with depression, worry, impulsivity, unpleasant past life experience, and previous suicide attempts. Prevention of suicide is worldwide community health goal. Since the increase of social media platform, people can express their pain, sentiments, and suicidal intentions. As a result, the online media have become screening tool for suicidal thoughts detection. And so early detection of suicidal thoughts can help people to create a consultation portal. So where social worker, psychiatrist, or family members can help the people to overcome from the suicidal thoughts. Coming to the problem statement, earlier suicidal thoughts in a person could be only detected from the family members or from the peers by seeing the pattern or the behavior of the person. Now, thanks to the online social media platform where people are expressive and share their feeling most of the time, so before they take any extreme steps. So just 1% increase in accuracy of correctly predicting the suicidal ideation can save hundreds or thousands of lives. Traditional models were failing to extract the contextual and syntactical information. So whereas graph can help us to overcome those challenges. As part of the literature review, so we listed out the real word usage of the graph. So it's being widely used in the information retrieval system in finding out some new medicines and also in the financial transaction. So we also listed out all different types of graphs like directed, undirected, and totally connected graphs, and different components and parameters are required to construct a graph. And so we also listed out the different encoder and decoder techniques for the graph. So like a deep walk, random walk. So we also listed out the limitations of CNN, so used on three-dimensional data, and how graph can overcome those limitations, and how to normalize the feature nodes in graph, and also like how text GCN can be used on classification of the text, and how it can be used on NLP related task. Moving on to the aims and objectives. So we had mainly three aims to study the feasibility of text GCN on the social media corpus. Text GCN was never tried on huge corpus, and to assess the effect of training data with the different volumes of training data. So on the traditional models, and to evaluate the results by varying different hyperparameters like window size, embedding dimensions, dense layers, dropouts, and learning rates, and also comparing these results with the traditional classification models. In the methodology, so we have defined the steps we have taken to meet our goals. The first part is data reading, cleaning of the data, and then exploratory data analysis and model building, so model evaluation, and conclusion at the last. Dataset, so we had collected the dataset from Reddit platform from the Suicidal Watch section. All the posts were extracted through the push shift API mechanism from December 2008 till Jan 2021. Data has two labels, text and the label. Text basically contains the corpus, and the label contains whether it's a suicidal or non-suicidal. As part of the data preparation, so we removed all the null values, all the duplicate values, all the junk and special characters, all emoticons, and we also removed all the extra spaces from the data as part of data cleaning. As part of exploratory data analysis, so we checked data for the imbalance. So we had so equal number of suicidal and non-suicidal data. So we also checked for the word length of each sentences before and after cleanup. Also, we listed out the top 15 rank words from the both suicidal and non-suicidal text. Also, we were able to create the word cloud from the suicidal text corpus and also from the non-suicidal text corpus. So we were able to see the difference in the word cloud, where suicidal talked more about the negative words, and non-suicidal had a lot of positive words. As part of model building process, so we first evaluated our model, varying the volume of train size split. So initially we had train and test split as 50-50%. So we were able to see the accuracy up to 92% on the test data, and so gradually we decreased it till 10%. So where 10% is train data and 90% is test data. And Graph did a great job in learning the pattern, even with smaller amount of train data. We were able to get the accuracy of 92%. So we also tried our experiment with 20 and 80% split, with 20 being the training data and 80% split is being a test data. So even with this, like we were able to get very good accuracy up to 92% on test data. As part of the model building, we also varied the window size while constructing the graph, by varying the window size from 10 till 25. But we didn't see any difference in terms of the test accuracy on varying the window size. But the processing took a lot of time as we increased the window size. So you can see the accuracy being plotted. So where the accuracy stays at 89% for all the window sizes. We also evaluated models varying the embedding sizes by making the embedding sizes from 300, 600, and then to 100. We were not able to see any major difference on the test accuracy. But with embedding size of 100, we were able to see the training accuracy going till 95%, though the test accuracy remained at 89%. We also did a comparison of traditional model, logistic regression, against text GCN with different volume of trained data. We use a split of 10 is to 90, where 10% is the training data, 90% is the test data. On text GCN, we were able to see the accuracy till 92, precision recall and F1 being 92%. So whereas in the logistic regression with 10% training data, 90% of test data, we were able to see accuracy only till 86%, and precision also being 86%, and the same goes with recall and F1 score. Coming to the results, so we were able to demonstrate the efficacy of TextGCN with relatively less training data. We had some limitation when working with TextGCN. So when varying the window sizes, we saw RAM being overloaded and the processing took more time. And also, so we went with just 2 hidden layers since so it was taking more time to train with our the limited resource of GPU. As last part of our PPT, we would like to list out the conclusion which we made running through the experiment using TextGCN. We were able to list out all common emotional words which are part of suicidal ideation text. We were able to see the major pattern like design and the topics revolving around people, state of mind or body in the suicidal ideation corpus. So text GCN performs better compared to traditional model since graph is made up of word or document to word nodes, which carries contextual information compared to the traditional models. TextGCN performs very well with a less volume of data. So even with 10% of data, we were able to get the accuracy up to 92% on the test data. So which is basically unseen data. So than compared to traditional model. So which was giving just 86% on the unseen data. Due to time and hardware resource constraint, so we refined using multiple dense layers. So we have used only two hidden layers. However, using multiple dense layer can improve the performance. So this can be explored in the future. We also recommend to explore different word embeddings and different embedding dimensions to construct a sparse matrix to see how well it works. We also recommend to explore some of the pre-trained embeddings such as glow to construct the graph. And thank you very much for watching my presentation on text graph convolution neural network.